World's Guide.
Supernovas are incredibly powerful and dramatic explosions that occur in space when certain types of stars reach the end of their life cycles. These events release an immense amount of energy and are among the most spectacular events in the universe. There are two primary types of supernovas, Type 1 and Type 2, each with different underlying causes. Type 2 supernovas are primarily associated with massive stars that are at least 8 times more massive than our Sun. These stars go through a series of fusion reactions in their cores during their lifetimes, with hydrogen being converted into helium, helium into carbon, and so on. Eventually, when a massive star exhausts its nuclear fuel, it can no longer support itself against gravitational collapse. The core contracts rapidly, causing the outer layers of the star to collapse inward. As these outer layers fall inward, they bounce off the incredibly dense core, producing a powerful shockwave that races outward through the star. This shockwave causes the outer layers of the star to explode outward in a brilliant burst of light and energy, resulting in a Type 2 supernova. Type 1 supernovas are associated with white dwarf stars in binary systems. A white dwarf is the remnants of a star like our Sun after it has exhausted its nuclear fuel. These stars are incredibly dense but stable under normal circumstances. In a binary system where a white dwarf has a companion star, the white dwarf can accrete matter from its companion. If the mass of the white dwarf exceeds a critical limit, known as the Chandra limit, about 1.4 times the mass of the Sun, it can no longer support itself against gravitational collapse. The collapse of a white dwarf under these conditions can trigger a runaway nuclear reaction, causing a rapid release of energy in a Type 1 supernova. The energy released during a supernova is staggering, often outshining entire galaxies for a brief period. Supernovas are crucial in the universe as they disperse heavy elements and other materials into space, which can later be incorporated into new stars, planets, and even life. Supernovas are also significant because they are responsible for producing many of the elements beyond iron on the periodic table through nucleosynthesis in the intense heat and pressure of the explosion. These elements are then scattered into space, eventually becoming part of the raw materials for new celestial objects. In addition to their scientific importance, supernovas have played a role in human history, as their visible explosions in the night sky have been recorded by astronomers for centuries and have helped shape our understanding of the cosmos.
World's Guide.